Welcome to today's lesson, more about the fundamental counting principle, but also about classical or theoretical probabilities. It says we've got two questions, but it's really just one that's got two parts, but each with subparts. The first part, question one, is about the fundamental counting principle. It says how many ways. If digits cannot be repeated, then for the first digit we have 26 possible letters to choose from, and then for the next letter we have 25, since it can't be the same thing as what the first one was. And for the third one there would be 24, because there's now two things that it can't be. The digits are very simple. 10 for the first one, and then 9 for the second one, and 8 for the third one. And when you multiply that out, you get 11,232,000. What if you can repeat, but you can't use vowels? And here I'm thinking about the A, E, I, O, U, the 5 vowels we have. So there's 21 letters to pick from for the first letter, and then 21 for the second letter, because we can repeat this time, and 21 for the third letter. And there's no restrictions on our numbers. So it'll be 10 times 10 times 10, any number we want to. And we get 9,261,000. And then part C, what if any combination can be used? So now we can use the vowels. So instead of 21, it's 26. And any combination means we can repeat. And we can also repeat the digits as well. We get 17.5 million. Now, just for the record, I put in number one just to put in another question and give you some practice. It's also a good example of using no replacement. Part B is how they constructed license plates when I was growing up, and then when I got to high school they decided they needed more license plates and they added vowels, and we got to part C, and you can see what a big difference that makes. You jump from 9 million license plates to 17 million license plates. You almost double the number of license plates just by adding vowels. But we're also interested in probabilities. So what if the probability that no digit or letter is repeated? Now, since it says if any combination can be used, so we know that our denominator is going to be this 17.5 million. And how many of those 17.5 million have no repeats? Well, in part A, we calculated that to be the 11 million. Oops, and I said part B, but that was part A. So for part B, you might think that it will be very similar and we're just going to divide again, but it's different. It doesn't say the probability that no vowel is used. It says the probability that at least one vowel. Now, this is not true in other chapters, but in chapter 4, when it says at least one, most of the time that means you're going to be using the complement rule. So I like to write it down very generally. So we're looking for, I'm going to call it E for event. You call it whatever letter you want to. We're looking for at least one vowel. And then since we said that the at least one is highlighting the complement rule, we need to think about what the complement of E is. The opposite of at least one vowel, you can think about it as two ways. It either means no vowels or it means all consonants. And the reason that's important is that is substantially easier to calculate than the probability of E. So the probability of E complement, again, in either case, no matter how we approach this, our denominator is going to be the 17.5 million. And how many of those have no vowels? Well, that's the 9 million from part B. The only problem with this is we're not done. We've calculated the opposite of what we need. But remembering that the probability of E is 1 minus the probability of E complement. So 1 minus 0.5269. So we get 0.4731. So again, just a hint, when you see that phrase at least one in chapter 4, be thinking about the complement rule. And as always, if you've got questions about this problem or any others, please feel free to contact your instructor.